Okay, so our previous theorem told us that if it's maximal planar, then the size of G is equal to 3 times the order of G minus 6. And now, one of the things is, from our definition of maximal planar, we said that if we had to add another edge to it, it becomes non-planar. So remember, maximal planar, if you add an edge, it becomes non-planar. So we know that the boundary for all planar graphs size has to be equal or less than or equal to the size of a maximal planar graph. So in other words, planar graph sizes are sizes, let's actually write the size there, is less than or equal to maximal planar size. And that is purely because with maximal planar, if you add an edge, it becomes non-planar. So, and the size is the number of edges, so obviously any planar graphs have to be less than or equal to it, because a planar graph can be maximal planar or it can just be normal planar kind of situation, which means you can add an edge to make it maximal planar. And again, sizes is the number of edges, so if you have to add an edge to get maximal planar, that means the size of the original graph is smaller than the maximal planar version of it. So this is where the next theorem comes into play, or comes out of. So we have a theorem that basically says if G is a planar graph or plane graph, then the size of G is less than or equal to 3 times the order of G minus 6. Okay, and again, makes perfect sense, but let's actually go ahead and prove it. So to prove it, we are going to look at two cases. So we're first going to look at the case where G is maximal planar. So if G is maximal planar, then the size of G is equal to 3 times the order of G minus 6, and we are pretty much done. If G is not maximal planar, so we're proving this directly. So if G is not maximal planar, then we can add an edge to G to get G star. So in other words, G star is equal to G plus the edge that we've added. And or we can add edges in, plural to get it to where it is maximal planar. So you add edges to G to get G star, and obviously if you have more than one edge, it's going to be, this kind of situation, which is why we don't actually put this part in there. That was just so that you can see what's happening. So you get G star, where G star is maximal planar. Then you have, if you have edges, to add edges to a graph, the order of the graph remains the same, right? So we have the order of G star is equal to the order of G, but the size of G is less than the size of G star. So from that, we have that the size of G is less than the size of G star, but we've added enough edges to make G star maximal planar, so we know what its size is. So we have that situation, which is 3 order of G star minus 6, but we know that the order of G star is equal to the order of G, so we can rewrite it as 3 times the order of G minus 6, and therefore we have that the size of G is less than or equal to 3 times the order of G minus 6, and we are done. So again, the whole idea behind this is we said, okay, we have a theorem that says if G is maximal planar, the size of G is equal to 3 times the order of G minus 6. And we know that the size of a maximal planar graph has to be less than or equal to the size of a planar, or it has to be greater than or equal to the size of a planar graph. And the idea behind that is because if you add an edge to a maximal planar graph, it becomes non-planar, so all the planar graphs have to sit underneath it in the line of sizes. So then we look at the theorem. We say, okay, if G is a planar graph, then the size of G is less than or equal to the order of G minus 6. And we go about proving it. So we prove it with two different cases. We say either G is planar or maximal planar. Then we know from that theorem that the size of G is equal to 3 times the order of G minus 6. And then we look at a case where if G is not maximal planar. And then we basically just add edges to this G until it is maximal planar. And then we know that even if we add edges to a graph, the order of the graph doesn't change, but the size obviously does change. The size increases. So then we have the size of the original graph is less than the size of the maximal planar version of this graph with all those added edges. And we know what the size of a maximal planar graph is, and then we just run through the formula so that we can get the size of G is less than or equal to 3 times the order of G minus 6.